Very good morning, students. Today lecture we go talk about the protective relays. Okay, so from the protective relays we have the relay is a device which detects the faults and initiate the operation of the circuit breaker. So in the previous session also we discussed about the relay. So now we'll total review of the we'll go to the total review of the relay. Okay, so what are the types of the classification of the relays that we are going to discuss on the today lecture. So here are the or relay is a device which detects the fault. So its relay not only works as a single, so it will combined with the switch gear equipment, that is a circuit breaker. Okay, so relay is the one protective device. Okay, so in the power system we need the one of the component protect the equipment. So to protect the equipment from fault to health support. Okay, so we need the device. So that type of device we are using as a one device is a protective device, that is a relay. So relay is a device which detects the only fault. Okay, not initiate the fault. Okay, so whatever the fault is occurred. So if in the line, if the triple L fault is occurred, okay, so it will detect the fault. Okay, so not isolate the fault. So isolation part is done by the circuit breaker. Okay, so initiate the operation of the circuit breaker. So isolate the fault section from the rest of the system. So whatever the healthy section is, so healthy section is also one of them. So to protect the healthy section, so we need to separate the that fault section, right? So that's why we the relay is a device which detect the fault and initiate the operation of the circuit breaker and isolate the faulty section from the rest of the system. That is a healthy section. So some of the terms we need to know about the relay. Okay, so what is mean here? We are having the primary relay, secondary relay, okay, and auxiliary relay, pickup level, okay, operating time. So let me discuss about the each one. So primary relay, which is directly connected to the protective system. So if the main bus bar is there, okay, so here the relay is connected to this one. So the relay is connected to this one, and so this the it will be there. Okay, so that will be another connection to the CB. Okay, so from the CT, okay, so CT and PTS relay will come. So that is a one primary relay, and second relay, that is which are connected to the CT and PT. Okay, so that is another different connection, that the second relay. Okay, so next auxiliary relay, so this will be which will be protective for the primary. Okay, so actually if this main system is failure, okay, so they have to protect the that's the backup one, that is the auxiliary relay. Okay, next it is a pickup level. So relay is operated above the threshold. So that is a threshold is nothing but a predetermined. So should we have the work, that is the predetermined. So we can say that is a threshold is nothing but a predetermined. So if so at what level it is a fault is occurred, okay, that we have to know. So that is nothing but a that's a threshold. Next, the operating time. So time between the fault identified and relay operate, that is the operating time of the relay. So here the fault, okay, so important act how the relay system is activated. Okay, so it so we can say that here we can see, so this is the bus bar. Okay, so in bus bar we are connected the line, so that is the line we taken, and here is the circuit breaker, and so the line, okay, so that is connected to before the bus bar. So how much is there? Okay, so line is connected this. Okay, so here seat is connected this one. Here is a CT. CT is nothing but a current transformer. CV is nothing but a circuit breaker. So here is the circuit of this one. So this one is connected to the, here is the relay coil. Okay, so CT is directly connected to the relay coil, and here is the trip circuit. Okay, so this one is the trip coil. So this is a relay trip coil. So here is the battery. So battery source which are required. There is a DC to operate the SIM, that is the circuit breaker. To operate the circuit breaker we need the energy, so that is the battery, that DC source we are connected. And here the fault, okay, so if the fault is occurred at this point, Okay, so the variation will be there in the CT. So whatever the predetermined, so that will varied in the current transformer, okay, value. Then the signal is given to the relay coil. So relay coil will be right. Okay, so this is for the under normal operating conditions. This will be okay. So if fault, okay, so if the fault is occur, okay, so under normal condition this will be closed. Okay, this will. So whenever the fault is occur, okay, so if fault is occur, the CT, okay, so sends the fault. Okay, so measure the abnormal current. Okay, so here relay coil use the energy and makes the all the current. So relay coil will do use the energy and makes the contact. Then here the trip coil. So whatever the here and the trip coil. So trip coil gets energy from the battery. Okay, pulls the move contact from the circuit. So to move the, okay, to move the contacts, okay, so from moving contacts the and fixed contact, so we have to make the power, right? So that will be collected from the battery. Next, CB is a separate the fault section. Okay, so here the fault section say that will be separated by the at the circuit breaker. So this is the during the fault condition. So how it will be run? So it will be trip circuit. Okay, so the contacts we can see, so this will be open under working conditions. Okay, under normal working condition, so this will be closed and this will be open. Okay, that is the under normal operating conditions of the relay coil and CB. Okay, so during the under working condition, so we can see the, so we can see that during the normal work condition, here is a bus bar, the line is connected to the circuit breaker and CT is working. So here you can see the relay coil is, it's open and battery is in as normal. Okay, so when if fault is occurred, okay, then it will be open. Okay, so that will be closed here and it will be the moving contacts will be like, okay. So this is the during the fault conditions the working of the relay. Okay, so normal working condition that will be different and fault condition that also different. Okay, so the contacts, so relay, so this is the how we can see it. Okay, so you can see the working conditions. So here is the zip file. So relay contacts, the 6 volt DC relay. So here moving contacts you can see, so how it is varying. Okay, so how it the switching contacts is there. So here's the relay circuit connections. What are the connections we'll have with the relay? So first part we'll have the primary winding. Okay, so primary winding CT and which is connected to series with the line protector. So if its line is there, so if seriously connected the, that is the CT. Okay, so primary winding, secondary winding will be there. Okay, and the secondary part will be in the CT. Okay, and relay operating current. So secondary part is the CT. Okay, so it's a relay operating contact. So that will be connected to the CB. Okay, so here is a CB is connected. And third part, the tripping circuit. This is a tripping circuit and source of the supply, that is a DC source, and the tripping coil. So it is a tripping coil of the CB. So this is a CB and relay stationary coil. So this is a relay stationary coil. So next we are having the different types of the relays. So based upon the technology, we are having the static relays. So based upon the technology, we have the electromagnetic. Next we have the static relays, and we have in the microprocessor based. Okay, so here is the one of the type, that is the electromagnet. So these relays operate by virtue of armature. Okay, that is the one of the winding will be there. So these relays operate by virtue of the armature being attracted the poles of the magnet or plunger being drawn to the solenoid type. Okay, so one winding will be there and which will be connected to the trip contacts. Okay, so here is the relay coil to the circuit breaker will be connected. So such relays acted by DC or AC. Okay, so here is the classification of the relays. So based upon the operation, so we having the electromagnetic relays, electromagnetic induction relays, electrothermal, physicoelectric relays, and static relays, electrodynamic relays. So in the electromagnetic also we having another classifications. Okay, so what different types, that is a solenoid type, armature type, and armature attraction type. Okay, so it is the different types of the here the based upon the operation. Okay, so we have the electromagnetic relays, electromagnetic induction relays, electrothermal relays, physicoelectric relays, static relays, electrodynamic relays. These are the classifications based upon the operation. So here is the one of the type, that is a solenoid type, that is a here is the electromagnet type. Okay, so is the one of the example for the electromagnetic. So here the supply, okay, so that will be connected here. So this is for the, this is connected to the circuit breaker and here is the supply system. Okay, so here is the, sorry, it will be connected to the CT. Okay, is there any variation? Okay, so this plunger will be moved to upwards. So if the fault is occurred, so here the plunger will to the connected to the this contact. Okay, that the contacts at the circuit breaker that will be tripped. It's the one of the type of the solenoid type. So it is the iron plunger, you can see the two trip circuit. Okay, so next we having the, so based upon the time of operation the relays, so how much time variation. Okay, so speed, we can say the time count. So one of the main thing is that to operate the minimal operation time, so if you take the most times, that is the, it will cause us the damage of the equipment. So we have to know, we have to know the which is minimal time required. Okay, so we having the classification. So time of operation, the relays are classified. So one is the instance relay, definite time lag relay, inverse time lag relay, inverse definite time lag relays. Okay, so first, so we are having the classification, right? So based upon the, it is instantaneous time. Okay, so instant which will can the, so transient system. So at that time it will need the, so instantly that will be checked. Okay, so instance relays, definite time relays, inverse time relays. Okay, inverse definite time lag. Okay, so these are the type. Next we have the, so each one. Okay, so instance relay. Okay, instance one of the which is no intentional time delay. Okay, so it will simultaneously switch on. Okay, that's why it is the instance time relay. Silent. So the relay contacts are closed immediately after the current in the relay coil exceeds the minimum calibrated value. So here coil. So in the instant relay, the it will be closed the immediately after the current in the relay coil exceeds the calibrated. So that is whatever the fault value is there. Okay, so if the fault values achieved by the relay, okay, then it will be closed immediately. That is the instance here relay, and the instant relay have operate time less than the 0.1 second. So that is the time, the operating time is, that is a 0.1 second. So next we have the relay is effective only where is the impedance between. So relay is effective only where the impedance between the relay and the source is small compared to the protected small section. Okay, so protected sections impedance. So in here, so that we can, so relay contact, so it will be contacts will be closed immediately, and the time, so time is less than the 0.1 second. So one thing we remember, so relay is effective only where there is the impedance between. Okay, so impedance between the relay and the source. Okay, so relay impedance between the relay and the source is small compared to the protected section impedance. So if the protected section is the zone is there, okay, so bus bar zone, so that will be the impedance value, okay, the impedance value, okay, the impedance value between the relay and the source should be compared to the, okay, small compared to the protected section in the, okay, so then only it should be effective. Okay, so if the impedance is high, okay, so relay protected zone and the protected, so relay impedance, okay, if it's vary, okay, so this type of the relay is not workable at that time. Okay, next, definite time lag relay. So definite time lag relay, so definite time elapse between the instant of pickup and closing of relay. So definite time elapse between the instant of pickup and closing of the relay contacts. And time setting, so here is the time setting is there. So time setting is independent of the amount of current through the coil. So here the time setting multiplier is there. Okay, so time of operation, so if the current value is exceeds this much of current, okay, suppose 5 amperes current is flowing for 10 seconds, okay, so should I operate the this, so then the it will have to operate. Okay, this type of the relays are called as a definite time lag. So if it is a definite time elapsed between the instant of pickup and closing of the contacts. Okay, so time setting is independent of the amount of current through the coil. So how much current flowing through the coil, okay, that will be time setting. So there is a different time setting for 10 amperes current is there, then this much of time you have to operate. Okay, because if transient current comes, okay, so at that time if this switched off, okay, so relay if the operate, so that is not possible. Okay, so at that time, so you have to operate the continuously. Okay, so should check, so either continuously is current flowing or only transient current. So next, for if very long overloads, so all time, okay, so all inverse time relays are provided the definite minimum time feature. Okay, so for very long overloads continuously occur, okay, so at that time, so all inverse time relays are provided with definite minimum time feature. Okay, next we are having the inverse time lag relay. So time operation inversely proportional to the magnitude of the accumulating quantity. So time of operation is inversely proportional to the magnitude of accumulating quantity. You can see the fault current and time operation. If fault current is increasing, okay, the time of operations will be decreasing. That is based upon the current. Okay, the relay operation time will be varies. Okay, that is in the inverse time lag relay. So if magnitude of the fault is high, okay, if the magnitude of the fault is high, the time operation is 1. So if that means if the fault current will having the 10 amperes, okay, that should operate at the below 0.2 seconds. Okay, if 1 ampere, so it should take the more time. That is the time lag. Okay, because these if these much of fault continuously flow, so if the operate the after 5 seconds, what will happen, so it will damage the equipment. If this much of like, if take the 5 to 3 seconds, that is the another different. Okay, that's the magnitude of the fault is high, then the time of the operation is very small. Next we have in the inverse definite minimum time lag relay. Okay, so we can say that is IDMT, inverse definite minimum time lag relay. So here the time of operation is inversely proportional to the magnitude of the smaller values of accumulating quantity. So here the time of operation, okay, so whatever the time is there, okay, inversely proportional to the magnitude of the smaller values. So here its operation time is tends to be definite for severe fault current. So if it's severe fault current is, that is a symmetrical faults. Okay, so at that time we have to close the immediate. Okay, at that time, so minimum time. Okay, so here the example is the 0.1 to 0. So here in the practical, the time, okay, so over 0.1 second 0. So that will be very less. Okay, so you should will operate in the 0.005 seconds of time also say. Okay, so can see that is the time is whatever that inversely current. Okay, inverse direct proportional. Okay, so with the silent features you can see time setting is independent of the amount of current through the cup. So here the current, okay, so that is a definite time level having the time setting multiplier. So based upon the current, so we can set the time for each different times of for different amperes of the voltage. Okay, next electromagnetic induction relays. Okay, so in this relay operates. Okay, so principle of induction motor. Okay, so relay purpose involving the AC quantities only, and they are not used for the DC quantities owing to the principle of operation. So we can discuss the electromagnetics separately. Okay, so there's the topics will be there for that is the electromagnetic induction type. We are having the different types of the relays. Okay, so in the electromagnetic, so that will discuss later. Okay, so that's separate topic for this one. Okay, next we're having the electrothermal. So first we'll discuss the electrothermal. So these relays operate on the principle of thermal effect passage current through the relay. That is thermal effect. So here the thermal effect, the heat. Okay, based upon the here we are using the bimetallic stress, so which will operate for the if heat is applied, that is a high current means, so it will be varied with the current. Okay, so the heat expansion will be there. Okay, so based on that thermal effect will be. Okay, so the relay operate on the principle of thermal effect of the passage of current to the relay element. Okay, such relays are operated both AC and DC. So this is the thermal relay. So here is the bimetallic strip. Okay, so this here we can see that is the heating coil we can found. So this is the heating coil. Here is the heating coil wire one. Okay, so bimetallic strip. So this is the bimetallic strip. So bimetallic strip, and here the third one we are having these are the relay contacts. Okay, and the spring. So we are having this is the spring, and the spring tension adjusts to the, so we are having this one. Okay, so spring adjusts to the shaded plane. Next, to supply or CT. Okay, so this is the supply or CT. Next, to set, okay, to trip circuit. So this is for the trip circuit. Connections for the trip circuit and insulated contact. So this is the insulated contact. Okay, so this is the thermal. So when fault is occur, so here the if it is faulty occur, these bimetal strip will be expand. Okay, so these bimetals will be expand, that will be given to the due to the expansion in the bimetallic strip, these contacts will be opened. Okay, so this trip circuit will be activated. Okay, so based upon the input, here the my relay contacts, the contacts will be closed at the time the signal is given to the trip circuit. Okay, this is the working of the thermal relay. That is here we can say that if fault is occur, so what will happen, these bimetals will be expand, so that will given to the signal to the trip circuit, so then the splunger will be moved on. Okay, and here the trip circuit open the circuit. So here the working conditions of the thermal relay. So mainly that is the operator is that, so it will operate that, so when the fault is occur. Okay, so if we are direct In the electromagnetic relay, so we are using the magnet. Here, instead of magnet, we are using the one bimetallic strip, so which will be operate by using the, that is the variation in the contact. Okay, so that will be variation with the heat. Okay, so that is a heating coil. So if the heating is increased, then the bimetallic strip will be contacts will be varied. Okay, that is a different, that's electromagnetic relay and bimetallic strip relay. Next, physical electric relays. So in these relays controlled by the physical system. Okay, so the relay controlled by the physical system and produce changes in one or several circuit. That is, here's a Buchholz. So here this Buchholz relay that will be used in the transformer internal protection system. Okay, so here's the internal system. So how it is working. Okay, so okay, we can see is here. So that is some. So his gas collection chamber. Here's the, this B is nothing, upper float is a lower float and oil distal. So where is the conservator tank? There the buckles replaced internally. Okay, so this will be says the any fault, so which will be causes the fault in the internal faults. Okay, that will be sensed by the system and that will be operated continuously. Next we have the static relay. So these relays are used for the device like transistor or obtain the operating characteristics. Okay, so next we have the electro. So in detail, okay, so we are having the in detail for the chapter, that is a static relays, electromagnetic relays, microprocess based relay. Okay, so in detail we are discuss in the further classes. Okay, here the relay is used for static device like transistor. Okay, that is all electronic component will be used the static layer. That is mainly, that is in the electromagnetic relays we are having the, that is wire wound. Okay, so in thermal relays we are having the bimetallic strip. Okay, but in the static layer we are having the transistors. Okay, so here transistor based upon the transistor working and so and ICs. Okay, and in the microprocess based relays we are having the microprocessor. Okay, so here the programming will be written, so that will be connected to the, here the input supply, strip circuit, time setter. Okay, voltage multiplier, so that is the coming to the microprocess based control. Okay, so microprocessor based relays. Okay, so here in the static relays, the here having the only, that is the electronic circuit. So this electronic circuit will having the combined with the transistors. Okay, so here based upon input signal, so which have to operate, so it's is exceeding the, so it's main because of the comparator, so it will work on the basis of the comparator work. Okay, by comparing the input signal and output signal, we will be work. Next we have electrodynamic relay. So here's a, so sorry, so this relay operates on the principle of moving coil instrument. So we're having the instruments, right? Moving coil instrument, moving iron type. So here the contacts. Okay, so contacts will be based upon the working, that is a moving coil instrument. Okay, in thermal relays, that is the effect of the electrical. Okay, so they do not measure temperature directly. So it is a model. So it's the bimetallic strip we are covered. Okay, so it's the main bimetallic sheet or reset, auto seat manual. Okay, so comprehensive, so you can see internal. So this is another bimetallic strip. So we are having the principle of operation of thermal, how it is construction. Okay, so in the bimetallic strip it consists of the two nickel iron. Okay, two nickel alloyed steel strips welded together having the coefficient. that is the bimetal strips, okay, consist of the two nickel alloyed steel strips, okay, welded together. The bimetal strips of the two nickel, and here the operation, the combined strip is heated, okay, and one expands more than the other, okay. So here is the operation, that is the, as the combined strip is heated, one expands more than the other, okay, and uneven expansion causes the bending of the, okay. So what is it? Combined strip is heated, okay, one expands more than the other, okay. So if the two bimetal strip is there, so one is expand other than the one, okay. So an uneven expansion, due to the uneven expansion, so it will cause as the bending of the strip, okay, that will be connected to the trip one. So then the effect can be used to obtain the closure of the relay, okay. That is there, okay. So what is the expansion, okay, due to the expansion, that is when the strip will be made. So due to that, can be, that effect can be used for the obtain the closure of the relay contacts. So then the circuit breaker moving the mechanism will be actuated for operating operation. So here is the main, that is the, we are using the heating, okay. By heating the two metallic plates, we are making the, so uneven expansion, okay. So if one is the expansion more than one, okay, that is the, it will causes the bending. So from that one, that will be close the relay contact, then that will be given to the signal to the circuit breaker. These are the specifications of the thermal relay, okay. So another way, having the overload relay type LR1, okay. So 3-pole manual reset type providing protection. So this is a phase balance different type, okay. So we can see different types of thermal relays, okay. So here's the, we can see the relay setting range, okay. So how much time setting, okay. So relay settings time will be also available, and 21 options of relay range from fully protect the electrodes, okay. So independent mounting will be allowed for. So here the 3-pole, okay. So this is the one of the 3-pole uh, protective relay, okay. So it will have the time setting range from 0.10 to 66, direct operated in 21 options relay range, okay. So we have time setting bulk plates. So we can say here, we can see, right. So here from this one, we can change the time setting variations for how much operations we have to operate, okay. So for different values, if fault occurred at the 60 amperes, at what time it should be closed, okay. So it should be open the contact, okay, that will be set here. So temperature indicates and controllers employing the thermocouple. So that is a useful information of the thermal relays. So some of the merits of the thermal relays, so it provides the time delay which prevents the circuit from the being opened by the momentarily high starting current, and short one. So it is the provide the time delay. So if we provide the prevent the circuit from the being open the momentum. So it will instantly, we can not open. So it will take the some time, okay. And we can the short orders, if it is the short time order, okay, that can be. So here at the time, at the same time, it protect the motor from the prolonged overloads, okay. So it will protect the for motors from prolonged. So if the high length will protect this, okay, that will be easily overload, okay. That will be protected by the thermal based relays, okay. And these, okay, some demerit, we can say that. So these relays are not suitable for the operation on short circuit. If the short circuit condition, okay, these are not suitable, okay. So that's we are placing for these thermal relays for the motor operations, okay. So the simplest thermal relay is used for the in motor starters. So and overload protection. So in, we can see this type, okay. So relay we can see in the 3-point starter, sorry, not 3-point starter, start to delta starter, okay. So we can see the start to delta starter. So there's a thermal relay contacts will be there, okay. So from the here the setting multiplier will be there, okay, how much current it is, okay, in the start delta starter. And overload protection devices. the application, here the holding current, how much it's did. Okay, so is the time. So here is a thermal overload relay used with the magnetic contact. So it's a magnetic contacts where here, and here it's showing the 4 point starter. Okay, so 4 point starter is showing the thermal relay which is connected at the line. Okay, so if the overload is there, it should be operated constantly. Okay, so this is all about the today class. In the today class, we have discussed about the types of relays, classifications, and thermal relay, how it is operating. Okay, so what are the applications of the thermal relay and how it is working. Okay, so this is about the today class. Okay students, this is about the only today class. In the next session we'll go for the continuous.